Hello everyone. Today let us start random variables. Probability for IIT JEE. Let us talk random today. I mean it's random variable. You have been asking for random variable, probability distribution, mean, variance and standard deviation. You will delight to know that all these are very well connected. Let us tackle them one by one. So, at the starting chapter of probability, sample space. So, today's contents: random variable, probability distribution, mean, variance, and standard deviation. So, see the definition of sample space. The set of all possible elementary events in a random trial or experiment is called sample space for that trial and is denoted by S. Discrete sample space. A sample space S is called discrete if it is countable or having finite number of sample points. Example of this: in roll a die, S is equal to 1, 2, 3, 4, 5, 6. And toss a coin, S is equal to H comma T. See the next definition: continuous sample space. If the number of sample points in a sample space is not countable, then it is called as continuous sample space. Example: S is equal to set of all possible real values in the interval 1 to 2. Random variable which is denoted by X. Probability distribution which is denoted by P of X. Next you have mean. You call it as mean, it is denoted by mu. If you wish to call it as expectation of X, it is denoted by E of X. Variance, which is Varx, denoted by sigma square. And standard deviation, which is positive square root of variance, which stands for sigma. Now, talking to random variable. Random variable, which is like a function, it is denoted by capital X, where the domain is sample space. Sample space is sample space of given random experiment. And output is always a set of subset of real numbers. So, random variable is a function x from S to R, where S is sample space, R is real valued function. See the figure, random variable x from S to R. So, by this figure, in a sample space, yes, there are sample points. So, take sample points one by one. You have to keep assigning them a certain value. How will you decide it? It will be in the given problem. So, there are two cases: discrete case, at most countable values; continuous case, every value in an interval; discrete random variable. If a discrete random variable x can assume values x1, x2, x3, so on, xn with respect to probabilities p of x1, p of x2, p of x3, so on, p of xn, such that p of xi greater than or equal to 0 for all I, and sigma p of xi is equal to 1, then x is said to be discrete random variable. See the example: toss 2 coins. S is equal to set HH, comma HT, comma TH, comma TT. Now, random x given as number of heads minus number of tails. Then x of HH is equal to 2 2 minus 0, x of HH, there are two heads and no tail. So it is 2 minus 0, that is 2. X of HT, there is one head and one tail, that is 1 minus 1, that equal to 0. X of TH, here also like the above, 1 minus 1, that is equal to 0. And X of TT, there is no heads, so 0 minus 2, that is equal to minus 2. Therefore, X is equal to set minus 2, 0, 2. Now, see probability distributive function. Suppose X is a random variable connected with random experiment and P is a probability function associated with it. Then f from R to R defined by f of x is equal to p of x less than or equal to x for each x belongs to R. It is called probability distributive function of random variable x. So, x from S to R is a random variable. If the range of x is either finite or countably infinite, then x is called discrete random variable. Now, see continuous random variable. Let x be a continuous random variable. Then, probability distributive function of x is a function f of x such that for any two numbers a and b with a less than or equal to b, p of a less than or equal to x less than or equal to b, that is equal to integral a to b f of x dx. Then see this figure, a random variable x integral a to b f of x dx, that is p of a less than or equal to x, that is less than or equal to b. So, a random variable which can take all real values in an interval a comma b is called continuous random variable. See this table, x is equal to xi. There are values x1, x2, x3 and so on, xn. This is random variable. And a probability distributive function. P of x is equal to xi. That is P of x is equal to x1. P of x is equal to x2. P of x is equal to x3. So on, P of x is equal to xn. First one is P of x is equal to xi greater than or equal to 0. And second one is sigma I is equal to 1 to n. P of x is equal to xi is equal to 1. So that is sum of probabilities is equal to 1. From above example, x, p of x. So random variable x, minus 2, 0, 2. And their probabilities 1 by 4, 2 by 4, 1 by 4. So probability of each of everything lies between 0 and 1. So p of x is equal to 1 by 4 plus 2 by 4 plus 1 by 4. That is sum of probabilities equal to 1. So that value is 4 by 4. That is equal to 1. So mean mu, that is sigma I is equal to 1 to n xi into p of x is equal to xi. So that is minus 2 into 1 by 4 plus 0 into 2 by 4 plus 2 into 1 by 4. So this is 0. So mean mu is equal to 0. And variance sigma square, that is sigma I xi minus mu whole square into p of x is equal to xi. So by expand this, we get sigma I xi square plus mu square minus 2 mu xi into p of x is equal to xi. So that is sigma I xi square p of x is equal to xi plus sigma I mu square p of x is equal to xi minus sigma I 2 mu xi into p of x is equal to xi. So this is sigma I xi square p of x is equal to xi plus mu square into sigma I p of x is equal to xi minus 2 mu into sigma I xi into p of x is equal to xi. So that is sigma I xi square p of x is equal to xi plus mu square into 1 since sum of probability is equal to 1 minus 2 mu into mu since mu is equal to sigma I xi into p of x is equal to xi that is equal to sigma I xi square p of x equal to xi minus mu square. Therefore, variance sigma square equal to sigma I xi square p of x equal to xi minus mu square or also variance sigma square equal to e of x square minus e of x whole square. So, what is standard deviation? It is positive square root of variance. So, that is equal to root sigma square. That is equal to sigma. See the problem? Random variable x, number of colleges to which you apply after exams. P of x is equal to x, probability of getting admission in college. So P of x is equal to x given as kx, if x equal to 0 or 1, 2kx, x is equal to 2, k into 5 minus x, x is equal to 3 or 4 and 0 if x is greater than 4. So if k is positive, then first one, find k. So, and the next one, probability of getting admission in one college. Next one, at most 2 colleges. And next one, at least 2 colleges. So, see the solution. To find the value k, we have sum of probabilities is equal to 1. That is, p of x equal to 0 plus p of x is equal to 1 plus p of x equal to 2 plus p of x equal to 3 plus p of x equal to 4 is equal to 1. So, where x is equal to 0, 1, 2, 3. Then that is 0 plus k plus 4k plus k into 2 plus k into 1 plus 0 is equal to 1. That implies 8k is equal to 1. Then k is equal to 1 by 8. Now, second one is probability of getting admission in one college denoted by P of x equal to 1. That value is k into x. That equal to k into 1. K equal to 1 by 8. That is equal to 1 by 8. And next one is probability of getting at most 2 colleges. Admission at most 2 colleges denoted by P of x less than or equal to 2. At most 2 means maximum value is 2. So it is P of x less than or equal to 2. That is P of x equal to 0 plus P of x equal to 1 plus P of x is equal to 2. So that is 0 plus k plus 4k is equal to 5k. That is 5 by 8. And next one is probability of getting admission at least 2 colleges. At least means minimum value is 2 denoted by P of x greater than or equal to 2. It is nothing but 1 minus P of x equal to 0 minus P of x equal to 1. That is 1 minus 0 minus k. That equal to 1 minus 1 by 8. That is 7 by 8. Thank you.